This is the personalized medicine track. As a clinician, I describe you as a 40-year-old white male with lung cancer. And then I describe the pathology of the lung cancer. So how do I take that phenotypic description and link it to the genotypic data and then produce a meaningful outcome to you, also based on your environment? We know your environment has a lot to do with this. The drugs that you're on have a lot to do with it, whether you're a smoker and what your family history is and what your ancestry. So all of this coming together to produce a meaningful recommendation at an individual basis for therapy for your tumor.
The biggest impact today is in using genomics to help define different populations who might be a candidate for a certain therapy, particularly in cancer. So, for example, the classic one that most people know is the BRCA gene in breast cancer, which may or may not make a woman more susceptible, but also more susceptible to certain therapies later. The next real interest is around this idea of tailoring therapy on a very personal level to the tumor itself. And you mentioned earlier the idea that, we classify the patient as a 40-year-old, African-American male or whatever, and then we classify the disease. And historically, we've classified diseases by, where did the tumor come from? It's lung cancer. And what kind of cell does it look like under the microscope? Oh, it's a squamous cell carcinoma, right, which means a flat, elongated cell, right? That's a pretty broad classification, and we're beginning to find out that maybe that's not such a great classification. Maybe we need to think about the genomics of each tumor and see how different tumors, even though they might come from different parts of the body, might be alike because they have the same mutations and therefore may be susceptible to the same therapies, which could be a big improvement over where we are today historically with cancer.
What you're beginning to see happening is the adoption of those kind of genetic tests where there is strong, clear clinical utility become the health panels of the future. When a physician, in the future will want to assess your overall health and where they ought to focus with you on areas of prevention and in their health planning with you. In the future, there will be a panel of tests, probably one that looks very different than the ones we offer today, but there will be a series of panels that clinicians will use as probably something early in life to help screen all those childhood things that someone might be susceptible for, and then later in life, something to kind of reassess where either things have changed or as individuals become focused on different types of conditions that they're susceptible to, there may be another kind of screening process for that.
What we really face in the research world is it's both a problem of lack of regulation and over-regulation. So there's lack of regulation from the government side to protect people who donate or who give their genomes for research, to allow this genomes to be shared and analyzed in different disease projects, in different research projects, in a safe and consented way. It's very hard today, if I wanted to go around and ask different projects to share their samples so that I can combine, for example, the cancer patients with the diabetes patients, so I can try to draw any better conclusions about my autism research. There is no mechanism to do that follows any regulations put down by any government organization. At the same time, there's a lot of regulation that impedes this collaboration to happen. A lot of it because there is no other regulation to tell us how to do it.
Well, I want to thank you guys very much for a lively hour here, a lively discussion. Please come to the Hangouts. Please come and join the discussions for us going forward. We look for a lively interaction and we look for your input. Thank you all very much.